geometry. Today's lesson is 4-2, apply congruence in triangles. Alright, so identify congruent parts. Write a congruent statement for the triangles. Identify all pairs of congruent corresponding parts. So when we do a congruent statement, we list them in corresponding positions, okay? So we're always going to list them in the same order so that I'll explain it more when we get there. Okay, so let's look at the first triangle. So we could call this triangle JKL. Typically, they like to do them in alphabetical order. So when you do see it, and you can name it in alphabetical order, do so. So JKL, it's a triangle JKL. Well, on JKL, we went from 3 marks, right? 3 arcs to 1 arc to 2 arcs. 3, 1, 2. So we have to go 3, 1, 2. TSR. Do you guys see how I did that? 3, 1, 2. So I went 3, 1, 2, so that they're listed in corresponding positions. And what I mean by that is that their angles are, that are congruent are in the same positions. So like angle J is congruent to angle T. Angle K is congruent to angle S. Angle L is congruent to angle R, right? You guys see how that works? So you don't even have to look at the diagram. Once you write this properly, it answers all of your questions. You know that angle J is congruent to angle T, angle K is congruent to angle S, angle L is congruent to angle R. In terms of sides, without even looking here, I know that side JK is congruent to side TS. KL is congruent to SR. JL is congruent to TR, right? First, second, second, third, first, third. I know that those have to be congruent. Does that make sense, guys? So if you write this properly, then you can fill everything in without even looking at the diagram, which is really super convenient and nice. In the diagram, DEFG is congruent to SPQR. Find the value of X, find the value of Y. So we need to use this congruent statement to know what goes with what. So we're looking for the value of X. We have an X here. Our X contains a Y. We also have an X here that does not contain a Y. So I know I'm going to probably be using this one up here. So let's just clean that off real quick. All right, so this one just has an X. All right, so QR. QR goes with FG. FG. So now I know that I just set this equal to this and solve, right? So let's do that. So we have 2x minus 4 equals 12. Add 4 to both sides. 2x equals 16. Divide by 2 on both sides. X equals 8. So we solve for our first thing, x. X is 8. What about our y? Well, let's look at our y's. So we have a y right here. And this y is angle Q. So angle Q goes with angle F, right? They're the third letter. Angle F is down here. So I know that I have to set that equal to 68. So let's do that. 6y plus x equals 68. We know that x is 8. So 6y plus 8 equals 68. Subtract 8 on both sides. 6y equals 60. Divide by 6 on both sides. Y equals 10. So our y value is 10. Could we have solved for the angle first? No, because we needed that x value to be able to solve. You can only have one unknown in the equation. Okay, so we had to start with solving for x first. If you divide a wall into orange and blue sections, go Gators, along with JK, will the sections of the wall be the same size and shape? Explain. Alright, so, orange and blue, orange and blue. Go Gators. Nobody else is feeling it? Alright, if you're not a Gator, you're Gator bait, so you know. Anyway, alright, so we're trying to see, will they be the same size and shape? Well, this AJ is congruent to KC, right? We have one set of congruent sides. We know that AD and CB are congruent. We know that JB and KD are congruent. What about their last last side. Do we know anything about JK? Isn't it congruent to itself? It's a shared side. If it's the exact same side, isn't it the exact same length regardless of which one it's on, right? Reflexive properties. You guys remember reflexive? Same thing equaling the same thing? This is where the reflexive property comes into play. That's why you want to say the same thing equals the same thing, because now that that's in common, they equal each other. Therefore, we have all equal sides, right? So, in the diagram, angle A is congruent to angle C. We also have angles, right? Our angle A is congruent to angle C. Angle B is congruent to angle D. These walls, your floor and your ceiling are parallel, right? So, alternate interior angles are congruent. All equal angles, all equal sides. They must be exactly the same, right? They must be congruent. Is everyone okay with this? Proving that all sides and all angles are equal? All right. So, let's look at the next one. ABGH is congruent to CDEF. Identify all pairs of congruent corresponding parts. All right. Well, angle A, I don't even have to look at the diagram right now, right? Angle A is congruent to angle C. Angle B is congruent to angle D. Angle G is congruent to angle E. Angle H is congruent to angle F. Right? Right? Side AB is congruent to CD. BG is congruent to DE. GH is congruent to EF. AH is congruent to CF. Did I have to even really look here? No. All the information can be taken from the congruence statement, which makes life so much easier. But they also do have some stuff identified, and they want us to solve for the x. All right, so what is x? Well, angle H goes with F, 105. So, if 4x plus 5 equals 105, subtract 5 from both sides, 4x equals 100, so x must be 25, right? Divide by 4 on both sides, you get x is 25. Plug back in. 25 times 4, 100, 105. Or you could just say angle H is 105. Why? Because it equals 105, right? They're the same. What is the value of x? X is 25. You guys okay with that? Right. Show that triangle PTS is congruent to triangle RTQ. Alright. Why is this roasted up here? These aren't even the same letters, so that's definitely from a previous page, right? Alright, so angle PTS is congruent to RTQ. Alright, well, we know that these are parallel, right? So alternate interior angles are congruent. Angle R is congruent to angle P, alternate interior angles, right? Angle Q is congruent to angle S, alternate interior angles. This angle right here, angle PTS, is congruent to RTQ. Why? Vertical, good. Vertical angles, right? They're across from each other when two lines intersect. They are congruent. Why did I say PTS and then RTQ? I named them in the same positions, guys, right? 1 mark, 3 marks, 2 marks, 1 mark, 3 marks, 2 marks. So try to always name things in corresponding positions. So we have all equal angles. We have all equal sides, right? PS is congruent to RQ. PT is congruent to RT. ST is congruent to QT, right? 2, 3, 2, 3, and so on. So we have all equal sides, all equal angles, therefore these things are congruent. we used vertical angles, and we used alternate interior angles. Find the measure of angle BDC. The angle BDC. BDC. So we're looking for this big angle right here. Okay? That whole angle. What do we know? That's 45. It has one mark. This is 45 because it has one mark, correct? This is 30 with two marks, so this is 30. All right, well, this triangle right here adds to 180, right? 180 minus 30 minus 30. 180 minus 60. 150. Linear pair it. 30, right? They add to 180. They're supplementary. They're a linear pair. 30. All right, so this is 30, and this is 45, and this is 180, because it's a triangle. 180 minus 30 minus 45 leaves me with 105. So if this right here is 105, and this is 30, what's the whole angle? 135. Right? There's only one piece of information missing, and I can get that one too, right? If it's 30 and 45, that one's also 105. And every single thing is filled in here, right? Up here would be 150. You could fill in every bit of information just going off of the fact that triangles add to 180. All right, so now we're getting into proofs, because geometry isn't fun unless you have a proof, right? You gotta have to think. If your brain's not hurting, it's not geometry. All right, so given AB is congruent to BC, DC is congruent to AB. So this is the parts that they've already given you, and why? Because they gave it, so it's given. All right, so now what else do we know? Here's a hint. It's a reflexive. Well, right here, right? AC is congruent to, can I say AC is congruent to AC? No. AC is 1 mark, 2 marks, so now I'm going to say CA. 1 mark, 2 marks, right? 1 mark, 2 marks, 1 mark, 2 marks. So AC is congruent to CA. Technically, they should have wrote it CA only because then it's in corresponding positions. They don't like to follow the rules all the time, but if it's on the EOC and they only have it listed as AC is congruent to AC, that's fine. But technically, it really should say CA because then they're listed in corresponding positions. All right, so that's still reflexive. So now we have all the sides equal. What about all the angles? Well, we know, here's a given, right? That these two sets of angles were given. So they gave us that this and this are equal. They gave us that this and this are equal, right? Those are the other listed of givens. So now we know that angle B is congruent to angle D. How do we know that? Third angles theorem. Third angles theorem is if two angles are congruent, then their third angles are congruent, right? Because if they have two angles in common, then their third angle has to be in common because all triangles add to the same thing, 180. So if two of their three pieces of information are the same, all of their information is the same. Okay, third angles theorem. So now, look at our proof statement. That's always what we end with. We write our proof statement. They are congruent. Why? Definition of congruence. All equal angles, all equal sides. Therefore, they are congruent. All right, so in the diagram, what is the measure of angle DCN? Angle DCN. So we're looking at this angle right here. Up in here, right there. So this angle, what do we know? We know that these are equal because they said so. We know that triangles add to what? 180. So 180 minus 68 minus 75 leaves us with 37. Where else do I put a 37? Right here, right? Vertical angles are congruent. Do you guys see this one tick mark? One tick mark says, hey, I'm equal to the other one that has one arc mark, right? One arc mark, one arc mark. So this is 68, this is 68. So we have the 68 and the 37, 68, 37. And this must be 75 also, right? Third angles theorem. All three angles have to be the same. Where 180 minus 68 minus 37 once again is 75. Be good with that? So our last slide of the day. By the definition of congruence, what additional information is needed to know that the two triangles are congruent? All right, so this is going back. So what additional information do you need to know? So this is example 4 and 5. NDC and SR. NDC and SR. Okay, so for these to be congruent, what else do you need to know for these to be congruent? So we know that they have all equal angles, correct? Do we know anything about their sides? We know that CN is congruent to RN, but what else do we need to know? We need to know about DC. We need to know that DC is congruent to SR, and we need to know that DN is congruent to SN. If we know those two last pieces of information, then we know that they have all equal sides and all equal angles, therefore they are congruent, right? So we just need to prove those last two sides. We just need to know that those last two sides are congruent, and then we know that the two triangles are congruent. And that is everything. I hope you guys enjoyed your lesson on 4.2, Apply Congruence and Triangles. Please like and subscribe, and have a great day.